So
Okay.
Juan Pablo got his BS degree in geology from the National University of Colombia. He's currently a PhD candidate in geology at the University of Houston, and he's published research on the tectonostratigraphic evolution of the frontier deepwater sedimentary basins of the Caribbean. And he's an expert in the implications for hydrocarbon exploratory personnel. Hey, take it
Thank you,
away.
Linda. Thank you. I don't know if I'm an expert, but I hope you enjoyed this talk today. So I'm very glad to present your I'm sharing my presentation, right?
Yes.
Okay, perfect. So as I said, I'm very happy today to present this talk, which is the crustal architecture of the Colombian Basin and its implications for the early evolution and hydrocarbon potential of the Caribbean Sea. As Kenneth said before, thanks to the Houston Geological Society for giving us the opportunity to present this today. And also, I want to thank the National Agency of Hydrocarbons in Colombia that who provided the data that I'm going to show today. So if we get a map of the Caribbean Sea and we start talking about the regional hydrocarbon exploratory context, you will find that there are regions, there are areas that are very mature where billions of barrels of oil have been discovered, which include Maracaibo, Eastern Venezuela, recently Guyana, which was the area of study of the previous talk by Kenneth. We also have Trinidad, we have Northern Cuba, but here, the central region of the Caribbean Sea is still an area that has not found billions of barrels of oil as these mature regions. However, there are some places along the Caribbean plate, like for example, Jamaica, that has the evidence of oil seeps that have been burning in rivers for more than 100 years. Recently, United Oil and Gas reported 2.4 billion barrels of unrisked mean prospective resources in the island, and there are some wells onshore that have found late Cretaceous oil. If we move a little bit more to the east, to Hispaniola, you can see that there are some wells too that have reported Cretaceous rocks stained with oil. There are live oil samples in the onshore and also some tar samples offshore in Hispaniola. And here on the regional stratigraphic column that you can see from the Northern Caribbean, we are talking about these potential late Cretaceous organic rich intervals, which could be generating these hydrocarbons. That's for the Northern Caribbean, but actually, if we move, for example, to Costa Rica, you can see here that there are some tribes that have used the oil from these natural oil seeps for sealing vessels and for religious rituals. And there in Costa Rica, we have a potential or a very good example of a world-class potential source rock, which is the Loma Chumico Formation, which has again an age of late Cretaceous from the Cenomanian to Santonian with a Keragen type 2 to 3 and TOC values higher than 15%. Besides that, here in the southwestern Caribbean, there are some recent gas discoveries like Gorgon, Uchuva in 2022, Orca in 2014, and the Perla field, which has reserves of around 17 TCF. And in the middle of all the regions that I just showed, we have my area of study, which is located here in the Colombian Basin. Just few things that I want to mention. First, the Colombian Basin is located in the heart of one of the world's large and last unexplored fan systems in the world, which is the Magdalena fan, which has more than 10 kilometers of sedimentary thickness. There are some reports that were published in the APG by former geologist of Anadarko, one of them, Brian Frost, who is actually here today, who reported that in this basin there are over 40 large prospects with AVO and amplitude anomalies. Something important to mention here is that there are no direct conventional well ties to the seismic data. So far, there are only DSDP scientific wells that have been drilled in the deep waters of the Caribbean. However, those DSDP wells also found late Cretaceous organic rich rocks. And this basin, the Colombian Basin, has showed evidence of thermal maturity based on the results from piston core samples and also from the presence of oil seeps. So I'm going to talk more about that later. So to start here, talking about the Caribbean plate, there are two main models that have tried to explain the origin of the Caribbean. The first one, which is the most widely accepted one is the Pacific Drift model, which says that the Caribbean was formed here in the Pacific Ocean, and it has been moving relatively to the east between North and South America since around the late Cretaceous. But there's also the in situ origin model, which actually says that the Caribbean was formed in the place where it is sitting today, and that the Caribbean crust is formed by extended continental crust, which is different from the idea of an oceanic plateau from the Pacific Drift model. The thing with these two models is that they were published during the 1980s, 1990s. The good thing is that today there's more seismic data set that has been acquired in the Caribbean, especially in the deep waters, that are bringing new insights into our understanding of the tectonic evolution of the Caribbean plate, which I'm gonna show later. So here in this map, you can start seeing the different tectonic terrains that we have throughout the Caribbean. We have the Great Arc of the Caribbean here in red. We have some Paleogene oceanic crust regions like the Granada Basin and the Cayman Trough, some regions of continental crust like Chortis and the Upper Nicaraguan Rise. But what is very interesting, and one of the objectives of this talk, is that here in the Colombian and Venezuelan basins, we have these regions that you can see here that are regions of thin crust. Usually the Colombian, Venezuelan basins have been considered as a large igneous province, an homogeneous, thick, large igneous province, an oceanic plateau. And one of the things that I'm planning to show here in this talk is what we think about the origin of this thin crust that we have been able to see with that more recent seismic data that has been acquired in these basins. One thing that we are planning to also show, this is something that we're working for a paper that it's going to be submitted close, we're close to finish, is that in the Caribbean, based on the interpretation of the gravity data, there are these potential inherited spreading structures, where you can see here these northwest to southeast potential spreading centers throughout the Caribbean, connected by these southwest to northeast transform faults. And what is very good about the project that we are doing is that we were able to get access to work with this 3D seismic dataset, which, as you can see, covers in the southern part the thin crust of that I showed before of the Caribbean plate, and near the northern part of the 3D we have the thick Caribbean large igneous province crust. So basically, what we are doing here and what I'm going to show today is the interpretation that we have done for this 3D data that was acquired by Anadarko in 2016 and processed by CGG, and how you can see the crustal variations of the Caribbean plate, how that has implications for our understanding of the origin and evolution of the Caribbean, and at the end, how that has huge implications for the petroleum prospectivity here of the deep water basins of the Colombian Basin. So before this, just to mention, I'm gonna show transects from the 3D going from north to south. So just remember, we're gonna move from the thick crust here of the clip to the south, where we have this region of thin crust. So this is the first transect. You can see here below on this map, it is located in the northernmost part of the 3D. It has a west to east direction here. And as you can see, there are some key observations that you can do. This high amplitude reflector that you can see in the base of the crust, that's the mojo, and it's very interesting how you can see that the mojo is it's abruptly shallowing here in this region, and that region of exposed mantle that you can see here on the seismic is aligned with the location of that transform fault that transform zone that I showed before on the gravity. So here to the southwest of the 3D, we have that potential spreading center that you can see here, and then aligned with the location of this transform zone, we have this abrupt shallowing of the mojo. This is our interpretation of that line. You can see that here we have a thick 16-kilometer thick crustal architecture of the clip, which is divided between an upper volcanic crust, a middle crust, and a lower crust. And you can see crustal thinning. You can see regions of extension, and something that is very important for this talk is that you can see that where we have the thinnest crust, where we have that transverse zone and the exposed mantle, that's where we have the thickest sac over that extent ridge. If we keep moving to the south, this is another line from the 3D, more to the south compared to the previous one. This one also runs from west to east, and as you can see here on the interpretation, here we have a crustal thickness of 14 kilometers. So basically, what this is showing us is that as we move from north to south, the Caribbean crust is thinning. It's getting to the thin crust that I showed before. You can see that some of the upper crust volcanics that are seen here as high amplitude reflectors are controlled by the presence of the normal faulting that we have interpreted. Again, you can see crustal thinning, and in the region where you have the thinnest crust related to the transform zone, you have again the thickest sag of sedimentary thickness. One important thing, and this is important to remember, is that this basin, the deep waters of the Colombian Basin, have not been drilled. But if we look at this map here below, you can see that there are some dredge samples around the area that have recovered basalts, usually from the same age, around the Turonian, the Coniacian, and the Santonian. So that's why we are assigning an age of Cretaceous to these volcanic deposits. If we move to one final transect, the one that is here in the southern part of the 3D, which is parallel to the two previous ones, you can see that here we have a crustal thickness of 6 kilometers. So basically we moved from a crust of 16 kilometers in the north to a crust of 6 kilometers, which is normal oceanic crust in the south, which shows the progressive crustal thinning that we have of the Caribbean there in the area of the 3D survey. Again, you can see crustal thinning here, and you can see that we have a flexure effect right here, which is when the Caribbean starts to get subducted below South America, and that's why you can see here this accretionary prism, which creates these four-way structures that are going to be important for our petroleum system analysis. So the key things to take home about the transects that we are working on and the interpretation that I'm showing is that there's evidence of spreading, there's evidence of extension in the Caribbean, and it's important to include that phase of extension into our understanding of the whole evolution of the Caribbean plate. The problem here is that since there are no wells that have drilled that crust or those sediments there in the deep water, we are not 100% sure about the age of that spreading. However, for this paper, for this project, we have compiled different pieces of evidence in order to do our interpretation. The first piece of evidence are the magnetic anomalies. So in this paper that was published in 2021 by Garcia, Reyes, and Demand, it shows that along this profile, these magnetic anomalies that are parallel to the spreading center that I showed on the gravity, those magnetic anomalies show an age of around 90 to 70 million years. So basically what that is telling us is that there was a process of seafloor spreading between 92 to 73 million years ago in the Caribbean. And what is very interesting is that when you compile the ages of the rocks, of the basaltic rocks that have been recovered from the DSDP wells and the dredge samples, those basaltic rocks also have ages between 92 to 73 million years ago. What that is telling us is that the formation of the clip, the formation of that basalt province, of that large igneous province, was occurring at the same time as seafloor spreading was occurring, which is something that is very similar to the formation of many other large igneous provinces, both in the Pacific and in the Atlantic. And based on that, that is why here on the 3D seismic dataset, we think we can see here seaward tipping reflectors, which are those volcanic deposits that are dipping towards the sun with the thinnest crust. And as you can see, they have this wedge shaped, and they are controlled by the presence of those normal faults. So the important thing here is that those volcanic deposits that we can see there on the 3D seismic dataset are syntectonic to the spreading. And as you can see here on our interpretation, those volcanic reflectors are dipping towards the area where we have the crustal thinning, and they are dipping to the area where we have the spreading center. So basically, we are showing that for the Turonian, Coniacian, and Santonian, there was a moment of extension, which was also related to the deposition of those volcanic rocks. With that, that's important for hydrocarbon exploratory activities because If you take those 3 DSDP wells, which are the only wells that have been drilled in this region, you can see that there were also Lateronian to Santonian sedimentary rocks that were recovered, which had this organic rich layer. So basically, as at the same time that the spreading was occurring and the basalts were deposited, you also had the deposition of organic rich layers, which have been recovered from the DSDP wells. And more importantly, recently the CVTH and our research group with Chevron, they published a paper where they did a rockable analysis for those organic rich Cretaceous intervals, and they concluded that first, those samples show good to excellent potential for hydrocarbon generation when you plot the TOC versus the hydrocarbon generation potential. And also after the rockable analysis, all those samples were characterized as autochthonous hydrocarbons originated from those Cretaceous sampled intervals. So basically what this shows is that the Cretaceous sedimentary rocks, those organic rich intervals that have been found in the DSDP rocks and that are located around the Caribbean plate that I showed at the beginning, they have the potential for generating and expelling hydrocarbons. The thing here is that if you see this transect that runs from the southwest to the northeast throughout the whole Colombian Caribbean margin, here is the location of one of those DSDP wells. Those are scientific wells, so those were drilled here in basement highs. That's where the Cretaceous rocks were recovered. And this whole region of the Colombian Basin, here you can see clearly the Magdalena Fan. It's a basin that has not been drilled. And remember that here you can reach sedimentary thicknesses of more than 10 kilometers. The interpretation that was published recently from our group is that here you have the region of normal oceanic crust, the thin region where you have greater accommodation space. That's where you have the greater amount of sedimentary thickness. And if you bring those late Cretaceous reflectors from the DSDP wells, you could argue that you can have those late Cretaceous intervals here in the deeper part of the basin. And that would potentially explain some of the gas clouds and the amplitude anomalies that I'm going to show you later that you can see on the sandy intervals here in the upper part. Here, this map on the lower right, it's a basin model that was published by Leslie and Mann in 2020 that shows here that in this area of normal oceanic crust, which is the one that you are looking at here, that's the region when you get the overlap between that thin crust and the Magdalena Fan, that's the region where those late Cretaceous rocks could potentially be in the oil generation window, and that's where you have the highest potential. Again, it's a basin that has not been tested yet. One important thing here about this petroleum system is that besides the DSDP wells and the seismic, the basin has showed evidence of thermogenic hydrocarbons based on other evidence. The first one are the piston core samples. This thing right here, this is taken from a report from Brian for the APG that said that they recovered piston coring from the Colombian Basin showed evidence of a liquid-based petroleum system in the ultra-deep water fan, and this is how it looks on the seismic. This is the location of one of those piston core samples that show thermal maturity, and you can see that below it you have more than 8 kilometers of sedimentary thickness. Exactly below that piston core you have here some amplitude anomalies or some disturbance in the seismic that could indicate potentially gas chimneys or something occurring there. And here in the deeper part, you have these high amplitude reflectors, which could be those coniation to Santonian rocks. So potentially the generation of hydrocarbons here coming from these potential source rocks could be the answer of why those piston core samples show evidence of thermogenic hydrocarbons, and it is aligned with the location again of that thin crust. This right here is an integration of everything that I have mentioned: the crustal architecture, the location of the source rocks, and the thermogenic evidence of hydrocarbons. So here we have our map of the Moho. You can see here the surface on the seismic. Here we have the zone of exude mantle related to the transform zone associated to that spreading system. And you can see that above that Moho, we have here the map for the top of that basement. You can see that aligned with the location of that exude mantle, we have this depot center, we have these troughs that are run parallel to the fracture zone of that spreading center. And here to the west, we have this thick crust, which is related to dipping basaltic reflectors. And here in this region, we have these faulted blocks that you can see are rotated and faulted. So the important thing here is that related to that extension that I mentioned before, we have the formation of these depot centers, these potential source rock pots. And if you look carefully here to the animation that I'm going to show, this is the interpretation of the location of these potential Turonian to Santonian rocks. So those basalt sediments that are filling the earliest stages of the Colombian Basin, they are located along those troughs, they are located along those fracture zones, they are located along those depositors, so that would create a trend of deposition of potential source rocks related to the whole crustal architecture of the Caribbean. And this is the mapping, and right here, this is the way you can see it on a depth slice. Here on the west, you have the basaltic flows with these very high amplitudes. Here in this region, you have these faulted blocks, these ridges, and then here in the central region, that's where you have your central deposit for your source rock pots, where you have some clear polygonal faulting and it shows a clear trend. Looking at this more regionally, again, this is the map for the top of the basement. We have here our main depot center aligned with the location of the transform zone. Again, here, that's where we have the deposition of these basalt sequences, our potential source rock. And what is quite interesting is that when you map the whole basement throughout the whole survey, you get an area of potential source rock deposition, which is aligned with the location of the main troughs, of the things where you have the thinnest crust. And when you plot the location of those piston cores that had thermogenic hydrocarbon evidence, those are aligned with the location of that thin crust of these areas that we are considering as potential source rock pots. And actually, you can see that these samples are following the trend of that spreading transform zone. So basically, the idea here is that crustal thinning, that process of extension and spreading, created source rock pots where late Cretaceous rocks could have been deposited, and those are the potential source rocks for the Colombian Basin. With that, this is the petroleum system that we are proposing here, and that has been proposed previously in other papers and reports, which is we have here a rough basement surface aligned with the location of the thin crust, and in the depot centers of that rough basement surface, we have these high amplitude reflectors, which are interpreted here that could be time equivalent to those upper Cretaceous rocks that were found in the DSDP wells. Here you have an overburden in order to potentially generate hydrocarbons and expel hydrocarbons from the deeper part of the basin. You have migration pathways that you can observe here on the seismic, and in the upper part where you have the Magdalena fan sequences with some sandy intervals, you have these huge four-way structures that you can see here, which have amplitude anomalies. You can see here that we can see bright spots, flat spots, cross-current reflectors, and what is very interesting is that many of those amplitude anomalies are conformable to structure. So again, none of these structures have been tested yet, but if you take this petroleum system, and if you remember at the beginning, those over 40 prospects that were reported by Anadarko for the APG, you could say that in case the presence of hydrocarbons are proven here, the Colombian Basin could be a world-class basin in the future, which is something that hopefully one day could be tested and drilled. With that, just to wrap up, this project, this work has huge implications for our tectonic understanding of the Caribbean plate. What we are planning to propose here, or what we are actually showing here, is that the clip was formed by oceanic crust that was thickened by massive basalt flows triggered by sea floor spreading, which is something that also occurred here in Manahiki, in the Manahiki Plateau, in the Walbes Ridge, in the Shatsky Rise, in the Onton-Java Plateau, in multiple areas of the Caribbean plate. And that would explain that crustal heterogeneity that we have in the Caribbean plate, where because usually the clip has been considered as an homogeneous thick crust, but actually what you can see here is that yes, we have regions where the thickest crust, we have an oceanic plateau that is thick, but we also have regions where we have faulted and stretched crust, and also regions of oceanic crust, and that is related to the formation by seafloor spreading tectonics. And again, that has a huge implication for hydrocarbon exploratory activities. This basin, as I mentioned many times before, has the presence of oil seeps, the presence of potential thermogenic hydrocarbons from the piston core sampling that has been done. There's the potential presence of source rocks from those Cretaceous intervals that were tested with the rockable analysis. There's evidently enough overboarding and potential reservoirs and seals from the deposition of the Magdalena fan. There are huge traps here that show good amplitude anomalies that show potential for this basin. And one of the key questions that I still have is that if those biogenic gas discoveries that I showed at the beginning from the shallower waters are is that biogenic gas for microbial activity, or is that biogenic gas product of biodegradation, fractionation, and migration from a deep water thermogenic petroleum system? That's something that I don't know, but that's everything that I got for today, and thank you very much again, and I'm open to any questions or comments.
Well, I know Anna Kruger had a question. Anna, do you want me to read it off the chat, or do you just want to raise your hand? If Anna, do you want to just ask the question, or do you want me to read it?
Oh, I can read it. So Juan, is there any heat flow data available in the area?
Very good question, Adam. I think I have a backup slide for that, but yeah, there have been some campaigns by the ANH, and I think also Anadarko did some analysis on the heat flow. And this figure right here is a compilation that was done by Luis Carlos Carvajal, which shows different values for the heat flow. Something that it's quite interesting is something that I have not included yet on this analysis, that when you get here into the thick zone of the Caribbean, for example, this region and this region to the north, you can see that the heat flow values are higher than the heat flow values that you have along the thin crust. You can see that the values get lower as you move from the north to the south. Maybe that's not related with the crust. Maybe that's just related with a huge deposition of the Magdalena fan, which lowers the heat flow. But it's something that I have not studied a lot. But yes, there are heat flow measurements in the area, and it's something that has been tested and modeled in that paper by CBTH and Chevron, Carvajal Arenas 2020, where they took the different values of heat flow of this basin and they did basin modeling in order to test which scenarios could have generated hydrocarbons. So I would really recommend going to that paper in order to get more insights into that.
Thank you.
How about Brian?
Great work.
Brian Frost was mentioned several times in this. Maybe he wants to make a comment. You got to unmute.
Yeah. Hi. I think excellent presentation. And what I find really strange is between Kenneth's first presentation and this one, the area of the Ranger well in the Guyana Basin, the seismic data that goes over it is very similar to these source rock pods that Juan is pointing out in the Caribbean. But the thing is that no one's got a well down to that stratigraphy. So you're always left with that question, well, okay, maybe it's a source rock, maybe it's not. But then you look at Occam's razor and you're saying, okay, if you look here, and this is an actual source rock down in these little grabens, then it's mature, then you're looking at a huge amount of potential direct hydrocarbon indicators in the seismic data that you don't see anywhere else in the world. I mean, there's thousands and thousands of square kilometers of these DHIs all throughout the tertiary section of the Magdalena Fan. And you're going, okay, where else in the world do I see that? And you see it in the Gulf of Mexico. There's huge areas in the deep water Gulf of Mexico that have a really thick tertiary hydrocarbon or a tertiary sedimentary section. But in the ultra deep Gulf of Mexico, you don't see any DHIs. So it's a riddle. But I trust seismic data because it's a physical thing that we can measure, at least the seismic response. And a lot of things can cause potential direct hydrocarbon indicators. But when they start to occur at the crest of structures and seem to be conformable with the structures, it makes, I want to say, gives you a high confidence level that something's going on here that's just not a stratigraphic anomaly. It's not just um, by the volume of what you're seeing. It's not something that's a local occurrence. It's something that's very widespread. And from what Juan said about the size of the Magdalena fan, the hugeness of it, and the hugeness of the quantity of potential direct hydrocarbon indicators, there's something really important out here. And I think it's not something unique. I think it has something to do with what we saw on some of the cross sections that Kenneth showed through Guyana, in that those little basins underneath the structures of Lisa and whatnot, down on the top of the oceanic crust, maybe that's a really good source rock, and that's the reason why Guyana is such a huge hydrocarbon province. Now, you have to have a very rich source rock to do that, but as Juan pointed out, that those Lomo Chimico shales in Costa Rica, I mean, those are the best source rocks I've ever seen. I mean, the hydrogen index from them was just off the charts. And they're really thick, and they conformably sit on top of pillow basalts. Now, I've never been a believer of having good source rocks at oceanic crust until I found these source rocks in Costa Rica. And I think that's a really good working model for what we see not only in the Magdalena Basin, but possibly what we're seeing on top of the oceanic crust in Guyana, Suriname. So I congratulate both authors that gave presentations today on the quality of their work and the things that were showing us that have yet to be, what's the right word, discovered or discovered. So I think it shows up as something really, really great for Guyana, Suriname, and for Colombia. Talk too much. Thank you.
Thank you, Brian.
Well, let's
Great
go
comments.
to Fang Lin, has her hand up.
Sorry, forgot to unmute myself. Thank you, Linda, for calling on me. I would echo with Brian. I think I would like to congratulate both students for outstanding presentation. I am really impressed by how much you could integrate the various information and looking at vast areas like that and present a very coherent and convincing stories. My question to Juan in particular, I mean, there's a lot we can discuss in the technical detail, what could be the alternative interpretation. But since, from my perspective, if I sit in the exploration geologist seats, what I'm thinking is given a large area like that with lots of positive indicators, do you know or do you have some thoughts about why why either the national oil companies or the international oil companies haven't gone there and drilled some wells? What was preventing them from going there and drill the wells?
Yeah, that's a great question, and I think mainly you can see it on the slide is this. You can see here the depth of so this is in meters. The water column is 4,000 meters. So it's ultra deep water. I think for today, there's not a well that has drilled 4,000 meters of water column, right? So I think for me, that would be the main reason. Also, I guess I don't want to get into the economics, but Colombia is not it's not a very stable country right now for exploratory activities, but mainly I would say that it's related to the water column. However, last year by the third or fourth quarter of last year, I saw I don't know what's the status of that, but I saw on the news that Oxy, which is the owner of all the blocks that are sitting here along this trend, they had a prospect that they were planning to drill in this basin. I think if they do that, that would be the deepest well in terms of water column, but I'm not sure about the status of that. But I do think that the fact that it has not been drilled, as you said, given the size of the prize here, as Brian used to say, is because of the water column. Is very deep water. So you would need something huge in order to make it economic.
Okay, thank you.
So also don't forget, if you had a question for Kenneth, based on his presentation, we're welcoming that as well. So Kenneth, what are your comments on Juan's presentation? Should he do more like what you've been studying, or is that even possible in his area?
Oh, it's definitely possible. It's would he be even better with the data he has access to? No, you did a great job, Juan Pablo. I saw this before and I was like, oh, it's gonna be amazing.
You
But
did a
no,
great job too, Kenneth.
but no, I mean, with the data you have, you can easily produce an Excalibur Basin model that similar to what I've been working on. I think you will be doing that, right? Correct me if I'm wrong.
Yeah, yeah. Just remember that for everyone, our group CBTH has done. Right now, we have published 2 papers on the basin models about on this basin, on the Colombian Basin. One by Leslie and Mann in 2020. The other one, Carvajal Arenas et al. Also 2020. So that's something that it's not something that has not been done. It has been done.
All right. Well, hey, Paul Mann, are you able to unmute, or are you still muted? It says my computer's acting up. So I don't know if Paul Mann wants to make any comments. He said before he was having some difficulty with his microphone.
Oh,
So, okay, so I guess you guys are all looking forward to finishing up on the graduate thesis and starting your jobs. And it's the most fun time of life. Let me tell you that. You're gonna have a blast, believe me. So, Charles, you got any comments?
Just beautiful work, both of you guys. And thank you so much for sharing it. It's a treat to see some major future potential, and very exciting. And lots of places, the de-risking is the bright spots. So anything to confirm up the bright spots, probably there's a lot of other analysis, but um, if you worry if the source rocks are charged and you have bright spots that conform to structure, that's a big de-risker. It doesn't take away all the risk, but it certainly someone's going to drill those, and maybe it'll be Oxy, maybe it'll be somebody else, but it'll be very exciting when that happens.
It will. And just something additional to mention, again, to thank Houston Geological Society and everyone for attending our talks. Since I think Dr. Mann is not available, just to say that both Kenneth and I are part of the CBTH consortium at the University of Houston, and our group and all the students that are part of our group, and we're still working on this type of projects, regional exploration projects relating to subsurface. We rely on a sponsorship, we rely on data providers, which are the key thing in order to make these projects work. So anyone who might be interested in being involved with our group, with our research, just feel free to keep in touch with me, Kenneth, or Paul Mann, and we're always happy to receive people in our group to just keep working and getting into more regions. So thank you very much again, everyone, for attending, and thank you, Linda, for organizing, and Steve. And thank you, Charles, for that University of Houston sign.
Yeah, well, thank you so much for coming.